99.999% of all internet traffic, including this video, runs on a hidden network of internet cables. Why should you even care about this? Because all modern life, including your smartphone, your laptop, your studio lights, and your Alexa device that helps you on automation of some work.
Alexa, remind me to do my laundry at 2 p.m. today.
Okay, I'll remind you at 2 p.m. today.
Is increasingly dependent on this network of internet cables. Join me today in this video as we find out how these internet cables, also known as optical fibers, actually work. If you're new here, my name is Seth, and today we're going to find out how optical fibers work and what makes them a better option compared to the copper wires or any other cables we have on the market so far. According to the submarine cable map, there are over 450 subsea optical cables connecting our countries and continents over the globe. This includes the 1,200 kilometer length Caucasus cable system that connects Bulgaria and Georgia, and also one of the longest optical cables called Faster. It is of length 11,629 kilometers, owned by China Telecom, China Mobile, Singtel, Time.com, Google, and KDDI. It connects various countries like Japan, Shima, Taiwan, Shikura, US, etc. That is just a small overview on how many internet cables are underseas. But if we look at the submarine cable map here, we'll find out that there are loads and more cable wires installed in oceans, including Africa 2, SAFE, then Oman, Australia cable, Saturn, Thailand, and there are a lot, Maria, Grace Hopper, and a lot more. But before we understand what makes these optical fibers a better option than the copper cables, let us first understand the principle or the physics that is used by these optical fibers. Okay, let's get to the principle that is behind the operation of the optical fibers. Now, the speed of light changes as it passes through a medium, and this change in speed is expressed as a refractive index. Refractive index, for matters of information, is a ratio of the speed of light in vacuum to the speed of light in a medium. Therefore, this variation in speed leads to another phenomenon called refraction. Now, refraction is the deviation of a light ray from its original direction. Refraction is the reason why swimming pools appear shallower than their actual depth. It is also the reason why when a pencil is placed in a glass of water, it appears to be broken. Therefore, optical fibers take an advantage of this principle and use it in a more sophisticated and useful way. But let us dig more deeper and find out why and how refraction is used by optical fibers. Now, refraction happens when a light ray passes from one medium with a certain refractive index to another medium with a different refractive index. Therefore, a light ray bends towards the normal when light travels from a less dense medium to a more dense medium, and vice versa. This interesting technique is used by optical fibers. Now consider this interesting scenario. When a light ray is incident on a glass slab or glass prism, and we try increasing its incident angle. For matters of information, an incident angle is the angle subtended by the light ray towards the normal. Therefore, if we try increasing the incident ray at a certain angle called the critical angle, the refracted ray will pass through the surface of the medium. Now, a slight increase in the critical angle will cause all the light that was incident to the medium to be totally reflected, thus bringing us to another phenomena called total internal reflection. This phenomena is used by optical fibers to refract data signals in form of light. When a light ray hits the surface of the core at an angle greater than the critical angle, it is totally reflected back into the core. Therefore, this happens time and again every time the light ray hits the surface of the core. But for this to happen, the core must be surrounded with a medium of less refractive index, such as air. But optical fibers are not assembled in oceans with no coatings outside. Remember, optical fibers have a diameter equivalent to a human hair strand. Therefore, they are very tiny that they can be even swayed by waves, or they can be destroyed by any other aquatic animals. So what happens? These optical fibers are then coated with another protective membrane called cladding. Now this cladding is also made out of a material called silica, but its refractive index is slightly reduced using chemicals, such that as light is traveling from the core, it hits or it finds a medium that has a slightly less refractive index. Therefore, it is reflected back into the core. The same thing happens time and again. But how is data such as an iMessage or a phone call embedded in light such that it makes a light signal? Now, let's take an example. For example, an iMessage. Let's say you want to send hi to your friend, HI. HI is first converted to zeros and ones, also known as binary code. Therefore, after conversion, your phone will transmit these zeros and ones in form of electromagnetic waves. These electromagnetic waves are detected by the nearby cell tower. Therefore, ones are detected as waves of high frequency and zeros are detected as waves of less frequency. Therefore, if the light is of high frequency, a cell tower generates a light impulse, and if the light is of low frequency, the cell tower doesn't generate any light impulse. Therefore, these light impulses are then transmitted by the optical fibers that are connected to the cell tower. Now, since the speed of light is very far greater than the speed of electrons, this makes optical fibers a better option than copper cables. Now, also on the other hand, now as electrons flow in a metal, they generate a magnetic field around a metal. Therefore, this can cause an electromagnetic interference, thus causing an interference in the data signals that are being transmitted in a copper cable. There are chances that signals may interact with the neighboring signals in the same magnetic field, thus losing some information, thus making optical fibers a better option than the copper cables. Now, I hope this video has given you a better understanding of how optical fibers work, and I hope you have gotten a lot of information from this video. Thank you very much for watching. Please check out my other videos. I made a video about space junk, it's also right here, check it out, and a video about supersonic flights. Please check them out. Thank you for watching. See you next time. Peace.